Now, so when we name these, for alkenes, we change the ending to E-N-E. For alkynes, we don't have that up here, we change the ending to Y-N-E. Okay? So here's the examples. Ethane, ethene, ethyne. Okay? Single, double, triple bonds. We're going to name a couple of them together. Because I know you guys are like, oh Lord. Let's look at this one. Bless you. It's an alkene because it has a double bond. What's the longest possible carbon chain? 5. So what's our root name? It would be pentane, right? Yeah. But it's not pentane, it's pentene. Where is that double bond is the question. Here's the key now. We always start numbering from the end closest to the double or triple bond. So this is 2-pentene, right? Because the 2 tells me where the double bond is. What do I have left here? That right there. What is it? It's a methyl group, isn't it? And where is that methyl group?
4.
It's on the 4 carbon. So this is 4-methyl-2-pentene. I guess I could write that legibly. Fair enough? Just like we did the other day. Except now the rule is double and triple bonds are more important than anything else, so you start numbering near the end where they are. Okay? You good? You think? All right, let's look at this one. How many carbons here? Nope. Somebody said it. 6. Why 6?
Because there's 3 right there with a line notes.
Yeah, there has to be 1, 2, 3, 4, 5, 6, right? This triple bond has to have 2 carbons right here, right? Even though it's not kink, they didn't draw a kink. What's wrong with how I numbered it? If I named it like this, it would be 4, what is it? Hexine, right? That's not right. It should have been numbered so that it was what? 2, hexine. Because 2 is less than 4, isn't it? So this is 2 hexine. Okay? See how the number tells you where it's located?
So you have to imagine those triple bonds have a C on each side of them?
Yes, they have to. You can't just have a triple bond in the middle of something. You gotta have 2 atoms on each end of it, right?
Okay.
Yeah, I probably wouldn't draw it that way. I probably would have drawn it like 1, 2, 3, 4, 5, 6, like that.
Okay.
Then it would have been obvious. They drew it like that to see if you were paying attention, right? Because you have to have carbons on either end, right? If it was going to go all the way from there to there, they didn't draw it like that, right? That wasn't how it was drawn. So. All right. Now, if you have a cyclo compound with a double bond in it, the double bond always gets numbered with a 1, okay? And when I number it, it has to include 1 to 2. Look, this is where the carbons are that are in the double bond. on one end and on the other end of the double bond. And this would be 3-methyl cyclopentene. Okay? Because the double bond always gets a 1. Bless you. Lots of sneezing going on today. Now, what if I had numbered it differently? What if I had numbered it 1, 2, 3, 4, 5? Right? That's not correct because this would be 5-methyl cyclopentene. And 3 is less than 5. So you number in the direction that gives you the lowest possible number.
What was that?
Okay?
Why is the 1 and 2 placed there?
Because the double bond is always between the 1 and 2 carbons in a cyclo compound. So it's always between the 1 and 2.
Okay.
And then this is on the 3. If I call this 1 and 2, then this would be 5-methyl, and 3 is less than 5. So you, in this case, we numbered going toward the substituent here.
So you want to go by the lowest number?
To the lowest number, yep. And we're going to do a couple here. This one's easy. We'll do this one together, and then I want to let you guys work on that one for a minute. Anybody want to try to name this one for me? If it didn't have a double bond, what would it be called? No double bond, what would you call it? Hex, it's not just hexane, but cyclohexane if it didn't have a double bond, right? Cyclo means ring, so cyclohexane, but it has a double bond, so it is cyclohexene. Very good. Now, I want y'all to work on this one. Rudolph, what you got? No? Getting close.
I can see why that would be a mistake.
Yeah. All right. Let's back down. So let's do it together. Let's start. Let's ignore this stuff over here. Let's look. Drop a little. Looks like a fish. Yeah. We got a better joke coming up later today. I want to keep y'all in suspense. Be good. All right. Let's ignore this stuff over here and ignore the double bond. If I ignore everything that's not just that, if I ignore everything that's just the ring, just let's look at the ring, it would be what? Cyclopentane, but it's got a double bond, so it's cyclopentene, right? So cyclopentene takes care of this whole ring, and what I say we're going to do, where we're going to start numbering? Here, right? 2, 3. Now what's happening at that 3 carbon? I have 2 groups on here, don't I? 2 separate groups. It's not one group with 2 carbons, it's 2 separate carbons, right? They're not in a chain, they're separate. They're both at the 3 position. So it is 3, 3, because they're both at the 3 position. You remember the other day what we did? This is 3,3 dimethyl cyclopentene.
So you have to have a 3-3.
3,3.
You can't just list 1 and 3.
You can't.
No, because that's different. What if it was 3,4 or 3,5? You got to tell where both of them are. They're both located at the 3 carbon. Right? Because what if this one wasn't here? What if it was down here? Then it would be 3,5 dimethyl cyclopentene.
Because 3 is lower than 5. So you put 3
Yep.
first. Okay.
That's a lot of stuff to remember.
Yeah, it is.
Explain how you number it again. Yeah.
I start with the double bond, and it has to, 1 and 2 carbons have to include the double bond. And I'm going to start numbering toward where I got some other stuff. So 1, 2, that gives me my double bond. Then when I get to 3, that's where my methyl groups are. There are 2 methyl groups, right?
I understand that.
Okay.
I was wondering, because I haven't gotten down like which way you count.
I start numbering away from them, but toward them, right? 1, 2 has to, between right here, 1 and 2 has to have the double bond in it.
Yeah.
Okay? So that's how I start numbering. Now you could have started numbering in the other direction, right, May? You could have gone 1, 2, 3, 4, 5. Well, it would have been 5, 5. 3, 3 is less than 5, 5.
So it has to be less.
Yes,
The smaller the number, the better.
exactly.